All right, kia ora everyone. My name's Ben Carnell. I'm the tech director at Rocketworks, and today you've decided to attend my talk, which is called Keeping Your Designers Happy. A little bit about us. We're Rocketworks. We've been a games company for about almost 6 years now. We started down in Dunedin with a bunch of indie projects. I hadn't joined the team yet at that point, but we're founded by the creator of DayZ, Dean Hall. His original endeavour for Rocketworks was to create a collaborative space down in the South Island where they could kind of experiment with organisation structures and make cool independent games and kind of work on little dream projects, which went really well. They've pumped out 2 great titles. The first one is called Stationaires. This is available on Steam right now. The best way to describe Stationaires, I think, is if you got someone with a PhD in fluid dynamics and atmospheric controls and an electrical engineer, and you got them to design Minecraft. So it has all of the cool kind of voxel mining approaches, but you also get to create really rad bases and deal with interesting things like oxygen density around your engines, or it'll explode your base. Another title we've got out is Out of Ammo. This was one of the first kind of really cool VR successes. It's just a fun, haphazard physics simulation VR game where you get to shoot everyone and kind of play pseudo town defense game. It's a lot of fun. But what I'm here to talk about is our latest project. So Rocketworks has endeavoured to create a new AAA studio up in Auckland, the city that we all live in, and we're working on a title called Icarus. Icarus is Dean Hall's next brainchild. It's his next entrant into the survival genre, and it has some pretty key points. It's got a massive world. We wanted to make sure that the maps we're exploring in were large and densely populated, so it felt like you were truly trekking through various standpoints of survival wilderness. We wanted to make sure that the game focused on PvE survival, so making sure that the environment and the unknown dangers of the wilderness and your own hubris are your main enemies, not other players. We wanted to make it AAA. We're really tired, well, not really tired, but we've seen so many survival genre games come out in early access or come out with low quality bars when it comes to certain things, some bugs, and they iterate and end up making great products that we all love playing. So, I know definitely don't mean to slide on the final products. We really enjoy those, but we wanted to make sure when we pushed out our game, it was AAA from the get-go, and it had a great first serving. But, every great game needs to continue to live, so we wanted to make sure that Icarus was also going to be a great continuous service product, something that you guys could come back and play over and over again, and something that we could continue to improve. Now, that means heaps and heaps of content, and that's something that I've always been excited to do, which is create a product that relies on voluminous content. And not only do we have the core game content, we've also got this idea of a split between your planetary survival and your gameplay up in space. With the key way that we try and, freak the player out and drive them to kind of tense, dramatic situations is when you're on a drop, there's a timer running. And if that timer runs out before you get back to your spaceship, you lose all your progress and your character. But that does mean that we've got double the content because there's now 2 zones. There's your planet loops and there's your space loops. So, in essence, what we had in front of us for Icarus was a high content throughput title that's going to have a lot of different mechanics. And just like any survival game, we are going to have a bunch of interconnected systems and a bunch of items that are going to be interacting with each other. And we wanted our designers and our content creators to feel free to be able to basically innovate, create new stuff, and create new awesome things and new awesome ways for things to interact with each other in the game. So we decided to go with Unreal Engine for this product, mainly because Unreal Engine is awesome and it's the best engine on the market right now. There's not much not much out there that really competes with it in terms of usability, breadth of feature set, regular updates. It really truly is a great opening into the cutting edge. Also, personally, I myself a lot of experience with Unreal Engine. I'd written a textbook, and I had worked with Unreal Engine in the New Zealand games industry for a few years, basically since Unreal 4 came into preview, really. So anyone who has worked with Unreal Engine, though, knows that all of that massive set of features, the beautiful blueprint system, which is great for our designers, awesome rendering engine, and it's made for multiplayer and all these wonderful things, comes with some pretty significant trade-offs. The big one being that anyone who's worked on a large Unreal project knows that eventually content contention and merge problems become a real issue. Usually you'll get blueprint bloat with large interconnected webworks of blueprints that aren't really evident the hierarchy or the composition nature or the relationships they're in. And that can lead to really fragile frameworks, things that mean that when you're trying to add content to your product, it'll break some other unknown thing, or there's this big wild west of blueprints. And these things can be corrected with diligent process and diligent naming conventions and making sure that there's good documentation. But it does mean that you have what we're trying to avoid here, which is designers constantly freaking out and stressing about what they need to do, how they go about doing things, and making sure that their innovation and freedom of thought is free thinking. So one of the two big things we wanted to solve with the cons of UE4 is the merge content contention on binary assets, and the second being janitors. I like to lead a no janitors team, which means that everyone feels free to basically clean up after their own code and is able to do so. Definitely always had, we have code reviews and we have great peer programming concepts, but when there is large cleanup tasks, it's really nice when it's easily cleanable, and it means that we don't have a lot of these kind of fragile frameworks that are falling apart on us. I could go through a few examples of those things, but I don't want to rag on any previous employers, any previous work environments. So what we've realized is that we need to be able to, for Icarus, with its huge content demands, create a network of things that can communicate with each other and allows us to create interesting interaction gameplay systems. Survival games are known for their building environments, for complicated automation chains, for tool flow-throughs, like getting water and providing that to an engine as a coolant, and the engine is outputting power, which can charge a generator, which can then push out watts for a crafting bench. These kinds of things, these networks of things is very important to survival games, but even on a simpler approach too, interacting with a bush, swinging an axe, and making sure that when you swing an axe and it hits a bush, what happens? So those things are obviously fundamentals to game development, and there is event dispatches and wonderful blueprint layers that you can use for that. But we needed to make sure that it was very scalable, that we could throw content at this machine. We could create a harness that would allow our designers and our content creators to kind of go wild and create multiple editions of items, make new interesting functionalities for things, create cool space items that you can bring down that do neater things than the mundane planetary version of those. Whether it's an axe that has a buzzsaw for a head, or maybe we want to shoot out like lumbering disc blades that chase down the nearest deer, just like those weird collar things in the Wild Wild West. We also need to make sure that on top of all that scalability, it was very maintainable. So that means making sure that our points of failure are identifiable, that they're well known, that we can track down our points of failure very easily. And those of you who have done expansive systems in Blueprint before know that this can be a huge, huge, huge issue. Now, the last and most important one for this is that it's mergeable. We all know that eventually there'll be some point in time where someone's checked out player character BP or a base blueprint class, and then that leads to 2 or 3 people kind of waiting in line for that to free itself so they can get their work done. And those kind of contention problems was the biggest slowdown that I'd seen in my experience running technical teams or just working in technical teams within a game studio. And this compounds magnitudely for design. The last thing that I want designers to be worrying about is per-force conflict issues and losing work and having to deal with repository systems to try and make sure they save or scrap their work. We wanted to make sure that, just like last time, designers didn't have to worry about those issues when they were developing content for Icarus. So as I said, the main point here is to make sure that it keeps our designers happy. So we need to come out with a system that is a network of things, that it's scalable, it's maintainable, it's mergeable, and it keeps our designers happy. So the first offering that we found for this is the gameplay ability system, which is a system that's been in Unreal Engine since 4.20. The gameplay ability system is a very robust, basically ability system network that allows you to create a network of things that can communicate with each other, that allow you to specify piecemeal reusable equipment factors. So you could create action factors, you could create an action that does a particular thing, and then you can say this object has classifications of actions, and you can kind of make abstractions of those things and kind of hot swap them out, which is really useful and really great. And a lot of the fundamentals of this gameplay ability system will be the unknown source of a lot of the ideas for the system I'm about to describe. We didn't do too much of a deep dive into the gameplay ability system as a team. I'd had some experience with it before, but looking back at it now, this would have been a great reference for us. A lot of the decisions we ended up coming to, we could have shortcut by really digging down into the gameplay ability system. When I did play around with it though, as I said, it came together in certain ways. It does create a network of things. via different communications and the gameplay tag system, which is awesome. I strongly recommend everyone to use the gameplay tag system for any gameplay logic networks that they're trying to create. It was scalable. It's designed to create growing and expansive systems. There is a demo that you can download that is a kind of small action RPG demo that uses the gameplay ability system for you to pick up items and do different axe swings and things, and it's designed for that kind of large content-wise development. And that also was brought into the fold with data assets and those new binary asset formats that are also very useful. And it's maintainable. You can create usable and generic pieces for refactoring, and you can kind of have these different actions be applied to different things in the gameplay ability system. These different abilities apply to different things, and that was really handy. But mergeable. Is it mergeable? No, it's not mergeable at all. Unfortunately, it still has a binary asset dependency. And then again, when we started to dig deeper into the gameplay ability system and tried to work out the scope at which we'd be working with it, we saw that it can be quickly convoluted and hard to track down the network of things, given that unless you follow a rigorous folder convention or a naming standard, your pieces of your gameplay ability system kind of scattered throughout your folder structure. We realized that it requires technical designers to use with specific gameplay ability system experience. Obviously, when creating any new systems, that is also an overhead, but we had a really hard time trying to find designers that were comfortable digging into not only Unreal Engine and the mass that is, but then also being comfortable enough with that to then work on this more advanced concept of the gameplay ability system. And that really falls into its last point, with maintainable. It was maintainable, but it was hard to find experts. And the last thing that we wanted to do was commit an entire project to a framework that we didn't know the in and outs of. And this is where we basically came up with when we decided to come up with our own solution. Now, the main point here being mergeable, and also before I get any further forward, because we want to have multiplayer PvE, it does mean that our gameplay ability system, or whatever that replacement needed to be, needed to work friendly with our backend, and would allow us to update really well, be able to patch things and patch object information, and we've solved some of those issues too. So what we came up with is called the trait system. Now, the trait system, in essence, is similar to a component system. In fact, the traits that I'm about to describe inherit from actor component. We effectively took what we see as the component system and allowed our core team to specify interfaces that our designers could fill out. And I'm about to break down exactly how that happens. So, as you can see here, Icarus Actor, which is our generic base actor class, just inherits simply from UActor. Icarus Actors can have any number of traits. Traits in this example here, we have actionable, hittable, and meshable. A trait will define a macro grouping of functionality. So actionable being that the actor, the thing that you have in your hand potentially, you can action it. When you click a button, it'll do something, and that's usually called an action. In the other sense here, we have a trait known as hittable. That means that when something hits this actor, it'll want to do something. It'll want to react to that hit. And the last one here we have is meshable. Now, this is very important. Meshable doesn't have any functionality that takes place. It is simply data. But that is just as important for the trait system. Each of these traits here are unique identifiers. They can be, not unique identifiers, but they are unique elements that we can ask and query an actor for. And also, the thing that traits have is they have behaviors. Behaviors are the specific functionalities that take place. So to quickly break down in more detail, as I said, traits are macro definitions of a functionality subset, which means that they kind of, if you wanted something to be interactable, a trait that is interactable would kind of cover all of the interface requirements for a interactable subset. So that means, what happens when you interact with it by pressing a button, what happens when you interact with it by looking at it, what happens when you interact with it when you pick it up. And this is where we started to make some very clear definitions around what traits were. Traits effectively define the groupings of data or an interface for the functionality subset of an object, but not the implementation. This meant that programmers and core team members could go, cool, for interactable objects, we want them to have this subset of functionality. We want them to be do something when you look at them, pick them up, yada, 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 just like the examples I gave before. And it allowed us to lock those interfaces and then at the same time expose what takes place when you look at something or pick it up. And we wanted those things to be described in those behaviors I mentioned before. The important thing to note about traits is they're defined in C++ and they inherit from UActor component. This allowed us to easily attach them to actors and also get immediate wins on the replication system. And a trait's functionality is completely defined by its behaviors. So it's a hard rule that a trait doesn't specify its own behavior, that is entirely left to the behaviors themselves. Another thing that's very important to note about traits is that a trait can have a one-to-many or a one-to-one relationship with the behaviors. This means that basically a behavior is the functionality piece, and a trait is the interface. And therefore, if you have, say, multiple actions that can take place, you would have multiple action behaviors. But if you only had one hittable behavior, like we described before, it would be a different relationship. So to describe behaviors in more detail, they give a specific definition of a trait's functionality, what happens when you press action. It can be as generic or as specific as required. Now, this is our reusable piece. The behavior itself allows us to specify whether or not the generic melee one-hand swing, which is something that you could use for axe, a hammer, or even a spear if you wanted to. We could create that simple behavior and then we could reuse it for all of the items that make sense. And that would handle things like when you click, it'll swing, it'll activate any colliders that are required, it'll start the animation montage that is specified for that section, and it'll do this kind of really nice generic melee one-hand swing that will have exposed data inputs that we can use for what animation plays. Or it can be very specific. It could be not reusable. It can be an action that is created for a specific item, like the atomic screwdriver automaton control action, which is basically just an example of us taking some very specific use case down the line for a very particular item wanting to do something. And both of those, either very generic or very specific, work very well in behaviors and can be created at freedom by the designers. So the parent interface for behavior is defined in C++ with specifically named events or virtual functions. So what this lets us do is a trait will have a set of events and virtual functions, and a behavior will have a set of events and virtual functions. Through the reflection layer, the Unreal Property reflection layer, we're able to bind those automatically. This is really cool because it means that a designer or even a gameplay programmer could create a behavior for actionable or hittable and go away and do whatever they want. As long as they have those named methods declared there, they will automatically get hooked up and fired. So I could go ahead and make myself a new actionable that when I have left click on the X, what actually happens is it throws it, or it turns into a grenade and explodes, or it summons a demon. It doesn't really matter. It gives me the ability to create that on a known named event, which obviously we specify in documentation. That that allows the designer to open up their creative juices. So the other thing that's really cool about behaviors is, much like the previous traits, they are also components. They are RPC compliant, meaning that we don't need to impact the usability of UE4's multiplayer system. We can make behaviors that call proper client server authority checks. We can do all of our validation. We can do all of our standard RPC sending. Really handy for us because we don't break what Unreal does best, which is being made for multiplayer. Now, there is some nuance we have here, given that we've got traits as components and behaviors as components, to avoid component bloat. In terms of, there's some hierarchy tricks where sometimes behaviors are actually traits, but I don't want to get too into the weeds around that stuff. What I do want to show you is the cool little bit of code. I'm not a huge fan of showing lots of code in presentations, but this is really neat. This is how we basically make sure we can do these bindings together. We simply use the reflection layer which is all thanks to UE4's macro magic. We iterate through the property fields in both the behavior class and the trait parent that it's being attached to. So the trait owner, I should say, that's being attached to. They'll find similarly named delegate events and they'll bind them. And it's really simple. It basically means that the trait component, the actionable trait component, has an on-hit delegate, and the trait actionable behavior has an on-hit method. And that will simply be bound. And then when we call the actionable component to actionable trait to fire its behaviors, it'll call on action, and then everything gets kicked off, which is really neat because it means that we can have multiple bound actions as well if we need to, and we can kind of have cool flow and event chains that branch off from this. Now, it's all well and good to have cool traits and behaviors and all those things created in blueprints, but that doesn't really save us all of the hassle that we're trying to avoid, which is contention and our ability to mitigate those large blueprint checkout flows, because basically what I just told you guys is we made a new way to create blueprints, which is not so great. What is really cool though is we realized when we're making the trait system that we wanted to make sure that as much as possible everything in our game was defined in data. Our objects are defined in data, our items are defined in data, our simple parameters can be found in data. This means that we can really lean into designers' strengths. We know that designers love data tables, or at least good tooling around data tables. And it means that there's common points of information for where our source is. So we can go ahead and know where all our items are by looking at our item static data table and things like that. What was really important is we wanted to make sure our data was easily queryable and logically stored. We wanted to make sure it was maintainable and searchable. We wanted to make sure that it was very easily transported to the back end. And what's really cool too is we can use it for validation. And then obviously the last one is that it's mergeable. Now, what data asset in Unreal allows us to do all of this? Well, turns out, Datatables. Haha, the literal U data table asset allows us to do this stuff for one very good reason, is that it's convertible to JSON. JSON is a fantastic object notation. It's ubiquitous, it's everywhere, and we can now use it as our fundamental transaction data type. So here you can see an example of where we've been able to go back and forth between the standard UE4 data table and a JSON description of an object. This is a more verbose example of what it might look like in the back end. So this is JSON that's actually describing an action. You can see that at the top, the name is generic melee one hand. We have provided a blueprint generated class, which is the BP actionable behavior generic melee. And you can see there's also some data parameters there, like the montage that's going to get fired, which sections are going to be there. So that is completely defined by the interface that us as developers decided to expose to design. So we knew that designers would want to have different functionality take place, which is why there's a behavior exposure there. And we also knew that designers would want to be able to do things like specifying which animations play, which sections of those animations play, being able to wait for a stamina action notify, being able to wait if you want for the action to complete before you can swing again, and the cooldown, those kinds of things. But, not everyone likes to program like we do, so we knew that we'd have to do some kind of better visualization of this information. The classic default is the data tables present to you in UE4. Now, those look kind of hard to read. They're not too bad, but as you can see, when you start to specify blueprint paths, it gets fairly convoluted. Multi-character lengths start to come into play, and it gets really hard to kind of at a glance figure out where things are going. Thankfully, we have a super talented tools engineer, and he made us a custom data table editor, which is super easy to use. Here I'm showing you the exact same information we just saw in two different formats. And now it's much easier to read. We can see immediately that the left-hand column are blueprints. We can then look at the montage asset type and see that the preview's there, and all of the information is kind of available at a glance. Now, that is the biggest caveat with the system. It does require some good tooling, and we were just very fortunate that when we created the system, our tools engineer had already started and influenced a lot of our design around the user interaction with our system, so that we made sure, again, we were keeping our designers happy. Don't shortchange tools. They keep your designers very happy. So as I said, I've already covered this a bit, but backend integration is very important. JSON's an industry standard. Purely JSON items means that we can patch our content very easily, which is great. We can basically update a JSON description for an item. It'll automatically, we can just stream that text down, and we can patch that text down, and it'll completely redefine how that item works, which means that if we want to make small value changes, or if we've got the binary content already existing on the client's machine, we can do little tweaks and changes to these JSON object descriptions, and that'll change what mesh the item uses, or what its cooldown is, or what its swing rate is, or how much damage it does. And we can make all of those kind of balance patches really nice and efficient. We don't have to go ahead and update whole blueprint binaries just because we've changed a couple values. Thankfully, with JSON for us, and as well as our devs, we can kind of wrap our heads around logical storage patterns for inventories, items, and player data, given that nested object notation is kind of the bread and butter of JSON. And it means that, we can do a one format for everything. So we can work with JSON in our game code, and they can work with JSON in our backend code, and it makes everything a lot easier. Now, so looking at what we know now, we can look back at our trait system flowchart. You can see we have an Icarus actor that is our generic base class, as I said before, and it has 3 traits. Now, the most important thing here that we can see is the small relationship between hittable and on-hit ouch. Hittable and on-hit ouch is actually one thing I wanted to declare, which is this is a one-to-one relationship, whereas this actionable has a one-to-many. To reduce content bloat, we made sure that what we actually ended up doing was having hittable inherit directly from trait component. So in this sense, this is actually just overriding the trait component with its own function definition. The designer, they don't know that. They're inheriting just like they would normally. They'd be creating their own behavior. But to us, it just kind of cleaned up a lot of our content bloat. So this is all cool. Now, the way that we tie all this information together with our traits and our data and our behaviors is the idea of items. So Icarus items are our way of materializing the trait system into the engine. They're a simple abstraction of our generic base class, which does a few more has a few more bells and whistles on it. It handles serialization of data, so that makes sure that all of our custom data information is properly recorded and replicated. and it handles any inventory management interfaces. So items, as you know, will be either in the world or in your hand or in a backpack. This items class helps us handle all that. And then acts as a harness to which multiple traits and behaviors will be attached. So the Icarus item effectively acts as the plug and play for all these traits and behaviors to get stuck onto. Almost all of an item's information will be defined in data. That's a very hard rule, and that's so that when you look for item descriptions, you can go straight to the data table editor. You can look up where your item exists, and you can find out everything about that item simply by navigating through those tables. That makes the designer's life really easy, and it also means that if we wanted to duplicate an item and change it slightly, you could simply duplicate a data row. So next will be that almost all items will be constructed in different states. So basically what that means is, an item will be either in your hand or on the ground, depending on context. And there's no point in having an item in your backpack have all of the hittable and interactable and highlightable components active on them while it's just simply in your inventory. So surprise, surprise, while it's in your inventory, we just keep it purely as data. When it's in your hand, it might have the actionable and the meshable traits active, but not interactable, because now that it's in your hand, you don't need to touch it anymore. Another important thing about items is they can have many traits. In fact, one item could have every single trait in the game if we wanted to, but it'll only have one of each type. And also, items can be queried for their traits or associated tags. So just like the gameplay ability system, we decided to incorporate the gameplay tags because in combination we have a now very mergeable and maintainable subset of information that we can update through data tables, and we also wanted to have logical information in there. So when you have a new behavior for, say, the bow shot, when it pulls back, it fires the bow, and the arrow's flying through the air, it can query against the things that it hits. It'll go, thing that I hit, are you soft? Therefore, I will stick into you. Does it have the soft gameplay tag? So once with items, that kind of wraps up all of our concepts around what these things are, and I'll be showing you guys some items in a quick demo in just a second. Before we go to those demos, though, I'd like to point out that I've got some absolutely non-solicited testimonies. These simply came to me naturally, I promise. But these are some of the opinions of the team around the trait system. I don't need to speak these out, but if you want to, you can pause the video and have a read. I thought that'd be funnier than this, but they're actually all very gracious and very praising. The one thing that Jeff Keane here points out, who created Unfortunate Spacemen, I definitely recommend checking out that game. It's very cool and it's free to play. Is that it's pretty cool and you think it's going to be really scalable, but it needs some GUI-based tools for creating and setting up items, which we have worked on and is probably the main crutch point of this particular system. So without further ado, I'm going to pull you into a demo, and in this case, I'm just going to show you some of the work that I was talking about. All right, so you can see here I've now loaded up our editor scene, and what I want to do is run around and show you some of our items and how we make those up, or at least one anyway. So if we click play, you can see we're now our character in the scene. You can see our legs, and I'm going to add a stone axe to my inventory. You can see that the stone axe has an appropriate icon. It has all the different things you want to expect from it. It can swing around. It pops in and out of your hand when you scroll to it on the hotbar. It plays a little animation on this in first-person mode, and if we drop it, we can see that it has an interactable. I can press F to pick it up. It highlights when I look over it, and also it says primitive axe, good at swinging, and it's also, and it gives me a durability readout. Pick that up. See it in our hand again. So what's cool is I can now show you what all that information is defined. So if I go ahead and open up the data table editor and open up our mother data table, which is called items static, you'll be able to see this is the mother table for all of our items in the game. Every single item in the game has an entry in this table. Vertically, you can see each individual item as it's specified, and horizontally, you can see the traits and their associated entries for that data. Let's focus in on the stone axe, which I can thankfully search to. And we'll see here that we've also got some validation checking, and it says here that the experience table for this has not been set. So this has automatically showed us that there's some information that's missing from this item, which is great, and we can now go ahead and correct that. But at this moment, I kind of want to show you guys all the stuff that defines this axe. So you can see the traits horizontally again, and we can see some traits here that directly specify some stuff that we just saw. We see there's a meshable trait. If we open that up, we can see that this is the mesh information for the axe itself. It lets us provide a mesh when it's in world. It lets us provide a mesh when it's in the hand. And we can look at the itemable one as well. And this shows us what it's called, its display name, its tooltip, and its icon. And also we can go ahead and look at its actions. So we can see that if we click on actionable, we'll see that it has a generic melee action mapping. And on left click, it'll basically invoke the generic melee action, which we can see here. The key example here is this actionable table. Lets us bind multiple behaviors to this actionable component. and these multiple babies could be any number of actions here. So without further ado, let's have a look at what we can do to this thing. So now that if I bring this back into our editor scene, we can see the X is largely fine. I just don't want to do that. But if we go ahead and look at our editor and we start to mess with some of these descriptions of these traits, let's go to the meshable element here and let's make it so that the world context, it actually looks like a berry. And then in the hand, it's going to be, say, some cooler version of the X. Let's go for the metal alpha X. So now we've made some adjustments there. I'm going to save that. And then we can change things here too. I'm going to change its display name to demo X. Let's call it demo X mega for fun. X mega. Demo X mega. We can change its icon. Let's change that to one of our extractors. And let's change this to a future X. Good at throwing. Why not, eh? Let's throw this X about. So before we go ahead and start messing with some action data, let's just, if we cut back in here, we can see immediately if I swap into that item, it repulls this new data. If I drop it on the ground, it's now berries. And if I pull it over, if I look at the berries on the ground, we can see that it says demo X mega, future X, good at throwing. And I can pick it up again, and it's in my hand. We'll also see if I left click right now, it'll swing just like the old X. Now let's go back to our data table editor, and we can go ahead and change the actions that we were just messing with. So instead of making it melee one hand, let's actually change this to our throw. Let's make it throw one hand. Let's add some data to it so it knows what to throw and how to throw it. So we'll go here and we'll add in the dethrowable. We can specify we want to throw like a wood spear. And before we go, let's quickly add something that'll describe to it, a trait that'll describe how this thing's going to fly through the air. So let's quickly specify a ballistics component. Let's go in here and call it a wood spear. Let's make sure we save all the data tables we just modified. Let's save those as selected. Let's come to our test area, scroll back to the actor, and when I left click now, it actually throws it. And as you can see, it threw berries. There you go. So I just went and changed an X from being a cool stone X, which we can no longer find now, but if I go demo, if I add stone X into my inventory again, execute, we can see that here it is. Here's my demo mega X. It's got the new icon, it's got the new functionality, and if I throw it, it turns into berries, which is quite fun. Now what's really neat is you might have noticed that I did all of that without actually closing the data, without actually closing the engine or stopping the run session. I can go back and I can go back to our actionable component. I can return this to generic melee one hand. I can get rid of this generic data that I have there. I can go and go back to meshable. I can change this to be SK StoneX. Back to mesh stone. And you know what, for fun, let's just change this to something else. Let's actually change this to the extractor skeleton mesh. If that's findable easily. There you go. Cool. And actually, let's do that both. Let's do both of those. Let's do that for both of those because that'll be funny. Save that. Come back in here. Add the X to my inventory. And look, there you go. Now I'm holding this giant extractor, and when I drop it on the ground, it looks like that. So as you can see, obviously it's breakable because you can do things like this and make stuff that doesn't work very well. But what you can do is kind of have this full freedom of customization. And if I go back to revert, if I revert these back to its previous state, StoneX. Actually, I forgot my own naming convention. X stone. Stone, and save this, come back in here. You can see everything's back normal. Cool. So that's just a quick demo of how how all the data tables work together and how we can define different functionality for these things. I'll quickly show you one of my favorite items that was made, which is our dev fireball, which is basically just a fireball that you can shoot, and it bounces and then eventually explodes. Oh no, I measured, threw it off the edge, my bad. Let's throw it this way. There you go. There's our dev fireball. It has a ballistics component, it explodes, and just like the X, but this time, whenever it detonates, it explodes. And that's kind of the fun situations that we can have in this game. Now, given that that has a ballistics component, we could load that into any of our ranged weapons, like our bows and our shotguns, and we can have all kinds of chaos starting to take place. But what it really means is that it's easy for developers to reuse and piece together different bits of information. I hope you've enjoyed listening to this presentation. And yeah, my name is Ben Carnell, and on behalf of Rocketworks, I want to thank you for coming along and checking this out. That's the trait system, and I hope you guys endeavour to make a system like this for your designers and your products as well. Cheers. Bye.